Hello, my dear students. Welcome you all to Sri Jaindra Rank Zone classes. I am your mentor and your friend for the subject chemistry, and I will be taking the organic chemistry. My dear students, as you all know that we have started hydrocarbons in the previous turn. Today I am going to start with alkanes. Alkanes, they are also known as paraffins. They are saturated hydrocarbons. They have carbon-carbon single bond. The carbon in alkanes is sp3 hybridized. The molecular geometry is tetrahedral. With bond angle of 109 degrees 28 minutes or 109.5 degrees. The general formula for alkanes is CnH2n plus 2. They are open chain saturated hydrocarbons, or they can be closed chain as well, where N is number of carbon atoms. They do not contain any functional group. Functional group. Therefore, unreactive towards most of the chemical reagents. Therefore, they are least reactive. And that is why they are known as paraffins. As param means little, and affins means affinity. Okay. As we have already discussed about the occurrence of hydrocarbons in the previous video, the major natural resource of alkanes are petroleum and natural gases. Okay. Natural gas consists chiefly of methane, of methane, around 80%. Okay. Along with it, ethane and propane, butane are also present. Methane is also known as marsh gas, also known as marsh gas, also known as fire damp. Okay. Homologous series. The alkanes, they have the general formula CnH2n plus 2. If N is 1, then it is CH4. If N is 2, then it is C2H6. If N is 3, then it is C3H8. So you can see if we add a common difference of CH2 group, means that is methylene group having 14 units of atomic mass difference, then we will get a series of compounds belonging to a same family with similar chemical properties but different molecular formula. Okay, nomenclature. The nomenclature of alkanes, suffix ane is added to the name of parent hydrocarbon chain. C4H10. It can be written as the root word is but for 4 carbon atoms, and the suffix is a and e. So the name is butane. Okay. This is condensed molecular formula. This is open molecular formula. You can also write it in the form of bond line representation. Okay. Now isomerism or isomers of alkanes. Alkanes show structural isomerism, as well as they show conformational isomerism. In structural isomerism, they mainly show chain length isomerism, and along with chain length isomerism, they show ring chain isomerism. And conformational isomerism includes staggered and eclipsed conformations mainly. There are many forms other than like anti-form. Okay, in case of cycloalkanes, alkanes exist in board conformation and chair conformation. All these conformational isomerism we have already discussed in detail in case of general organic chemistry. Okay, like methane, ethane, and propane. They don't have any isomers. Okay, C4H10 butane represents two isomers, N-butane and isobutane. N-butane, okay, and isobutane. Okay, pentane shows three isomers, N-pentane, isopentane, neopentane. In case of hexane C6H14, there are five isomers, one is hexane, another one is 2-methylpentane, 3-methylpentane, 2,2-dimethyl butane, 2,3-dimethyl butane. Okay, understood? Now, the number of constitutional isomers, all these structural isomers are always what constitutional isomers. For C7H16, 9 isomers. Okay, 9 isomers. Out of these 9 isomers, 2 are chiral and exist in enantiomeric forms. For example, 3-methylhexane. This is wedge solid. This is wedge dash. Okay, this is S form, RNS configuration we have discussed. 3-methylhexane, optical isomer. Solid wedge. This is R form. Okay, these two are optical isomers. So the carbon-carbon single bond, that is sigma bond alkanes, are formed by, as you know, linear overlap of sp3 orbital of one carbon with sp3 orbital of the other carbon. Okay. Most importantly, the carbon-carbon bond lengths in alkanes are 154 picometer, while carbon-hydrogen bond length in alkanes are 110 picometers. Okay. Most of the molecules of ethane and propane exist in their staggered conformations, as staggered is more stable than eclipsed. Exist in staggered conformation. For butanes, most of the forms are anti-form. Okay. Anti-conformation. All other alkanes have all anti-conformations mainly. That is, any 4-carbon segment of the molecule adopts anti-butane conformation. Like for example, H H. This is the entire conformation of butane. So this is about the nomenclature, general properties of alkanes. We will be discussing physical properties in the next turn. Till then, bye bye. Take care. Stay safe. Stay healthy.